This is homework. This is question 2. First is the wide sense stationary process, which is WSS. A stochastic process is WSS process if its mean is a constant and the autocorrelation is a function of time difference, which means tau. And the second, independent increment process, which means the difference of xt1 and t2 with the difference of xt3 and t4 is independent. There's no connection between these two time difference. They are independent. And the third is the Markov process. Markov process is that the past of xt has no influence on the future when we know the present. I think it's a little similar with the independence increment process. And these two parts, I will take an example of these two parts. It's a Poisson process. Poisson process is WSS and the independence increment process, of course, and of course the Markov process. Imagine that when I wait for a bus, and if every time if the probability that I wait for a bus is the Poisson process, the probability will not change whether I went to the bus station, which I mean the time that I arrive at the bus station and the time I wait for a bus will not change the probability that I wait that the bus come. And so fourth is the normal process, or also the Gaussian process. The process xt is said to be normal if it meets this formula, and we know. I think it's a little similar to the normal distribution, and here we know the lambda and the c. The normal process is determined in lambda t and hw10q2, and 5 is static strict sense stationary process, which means SS statistics is not affected by a shift on time on the time axis. Its meaning is this formula, and I think it's real. The SS process is real. The 6 is white noise. It's effective of VT is 0, and the RT1T2 is means qt1 multiplies a function of tau. I mean a swash of tau. The final is mean algorithmic process. Xt is called algorithmic if its statistics can be determined from a single sample, and mean means the mean of xt equals to this formula.